today we're going to build on what we discussed in the last 2 lectures of discussing pointers. And if you look into this, this is not new information at all. So there is no new theoretical information. We're just putting pieces together. We discussed arrays alone. We discussed pointers, and we discussed that pointers are addressees for another variables. And we also know that pointers are variables themselves. So putting all these 3 pieces together, we will see how you can have a pointer to a pointer or arrays of pointers. Because if a pointer is just a type, why I cannot have an array of them, right? So in C programming terminology, this is called array of pointers or simply pointer array. How to do this? Similar to defining a normal array where you define the type and then the name of the array and the size. For example, this is float or int or whatever. You just put the type as your pointer definition. Good. So this allocates an array of 3 pointers. What would happen in the memory is you would create this thing, and every element of the array would be a pointer of its own, right? Then later, if I define 3 different arrays, this is just normal arrays we have seen before, A, B, C. A would have 1, 2, B would have 3 to 6, and C would have 7 to 9. Now I'm creating 3 arrays in memory, all of our type int. You can now kind of expect of what we can do. I can make the first pointer point to array A. This is what would happen. Second pointer point to B, and third pointer point to C. All these 3 steps we have seen before, except maybe defining an array of pointer, but every one of them is just a normal pointer that can point to an array. We have seen this last lecture, and we are just putting all of this into one array for now. Good. So looking into this, what if I want to access now these elements? The simplest thing is to access them using, so remember, A is also pointing to the first element here, B is pointing here, and C is pointing here. The simplest thing to access the second element in A is just say A1, right? We are familiar with this. But what if I want to access this through the pointer? Last lecture, if we said there is a B here, I can also say B1, correct? Or do a dereferencing for like this thing, B plus 1, right? We have seen this in the last lecture. The only change, the only tweak now is this B is just not a simple B, it's an entry in an array itself, right? So if I want to access B1, the way I would write it is to say, what is the name of the pointer? It's BB0. Now 1. So it's like a 2D array, right? The first one is the pointer itself. The second one is just the first element here, right? You see that? So if I just say I want to refer to element AJ in the array J, I would just write BB0, which is taking me to the first pointer, which is pointing to A, and then add the subscript or the index of A. The same thing if I'm doing this for B. It would be BB1 because BB1 is the pointer pointing to B, and then index J. And then lastly, the same thing for C. Let me see if there are questions here. Okay. Okay, perfect. So now, remembering the 4 different ways we said we can do to access an element in an array, I can also do the similar thing. A1 is just the normal way of the array. BB01 is using the pointer or doing the dereferencing itself. How I would do the dereferencing, similar to this one, but now B is replaced by BB0 because it's the first element in the array. So this is equivalent to this, equivalent to this. Good. The same thing if I want to access certain element in B or in C, right? Perfect. Continuing with the same example, so let's see what we can, we are just defining it in a different way. Here we define the 3 arrays separately, and then I made every single one of these point to the array name. What I can do instead is I can initialize my pointer array by saying A, B, C, right? Doing this would also make, so let's just forget about this for now, would also say BB0 is A, BB1 is B, and BB2 is C. So this is completely equivalent to the last slide, but the difference is I'm doing the declaration and the initialization in the same line. Good. Remember, we also said it's not a good idea to use pointers to initialize arrays. So it will give you a syntax error, right? So the same thing applies for arrays of pointer. You cannot just simply say, I know that A has 1 and 2, so I'm going to replace this with 1 and 2, 3, 4, 5, 6, or 7, 8, 9. Can someone remind me why this is giving a syntax error? We have said this reason when we discussed why it's not a good idea to use the pointer to initialize an array. They don't have address. Okay, it's I see what you mean, Nicole. You are correct, but we might just say it in a more clear way or in a different way. Not enough memory. That's correct, Gutung. So simply by just defining this, you are declaring. No. By just defining this, you are declaring this place in memory, right? Which is saying, define to me 3 places in memory. Each one of them is going to hold a pointer value, which is, for example, if you have 32 bits, these are 4 bytes. But you have no place at all for creating this. So the memory is not allocated, so you can just initialize it, right? Good. So one extra step, we always do this. We discuss arrays and then we say, what about strings? Because strings are special arrays of characters, right? Can I define arrays of strings using pointers? So let's see. Last lecture also we discussed this, how to define a string using pointer as an array of character. Now arrays of strings would be like 2D arrays because the string itself is an array of its own, right? So you can do this by saying I'm defining a pointer of arrays of type character, and then every one of them is going to point to something like this array. How I would do this? First of all, we have 4 elements of pointers, so 4 pointers, and every one is going to point to a different array, which is, oh, I got unstable, so I might get disconnected. You guys lost me for some time. Am I back now?
Yeah, you're good.
Okay, 2 seconds. Thanks. Thank you. So what I was saying is, we know that strings themselves are arrays of characters. So this is why we have these 4 arrays here. Each one of this is representing a character array that is ended up by the null pointer, by the null character. And by just writing this statement, I'm defining 4 pointers of type character. Every one of them is going to point to one of these. So the first one is pointing to the first letter, which is M, 2, 2, 1. Good. Now assume I want to do some kind of operation or like an algorithm on this. For example, exchange or interchange 2 strings. Let's say, for example, I want to change or exchange this one with this one. What I would do is simply, okay, let me see if there are questions. Isn't this defining an array while defining pointers? It's defining an array of pointers, Salah. So it's here what I'm doing is, this is saying this is a pointer array of type character, right? So this is defining the pointer array itself, right? So can someone suggest how can I, what is the easiest way to just exchange these two, to interchange them? This will show the benefit of pointers, is how to simply just change 2 things. Using a temp pointer, casting. Yes, I need a temp pointer, that's correct. But what would be, like how I would just simply do it? Why doesn't this give the same problem as the last example? Why? Yeah, Katie. So in the last thing, that's a good point. So here, remember last time we discussed that you are not allowed to use pointers to define and initialize arrays except for strings, which will be in the read-only memory. Remember, we discussed this. So for strings, they are allowed. This is the reason why you can do this now. But every one of this would be in the read-only memory, so you'll not be allowed to change. For example, you cannot change A to something, but you can move them around. So assume I want to change to SH4 and to SI4. What I would simply do is just exchange these 2 pointers, right? So what I would say is, I know that this one is pointing into to SI4, this one is pointing to SH4. So what I would do is take this into a pointer, put it into the which one okay, I'm exchanging to SH with 1D, doesn't really matter, and then make this one point to this one, right, through the temp. By just doing this, we change their order in the the pointer array, right, which means now 1D4 comes first before 2SH, right? You can make S array 1 point to SI4. Yeah, this is exactly what we are doing, Danny. Yeah, thank you. Good. And we're using a function called swap. Something I want to explain to you here is why we have these two. This is the first time we see this. We have 2 asterisks, not just 1. What does it mean? What I need to pass here, that's something that is important to discuss. If I'm exchanging these, that means I need to pass S array for the first one. I need to pass S array 1. And for the second one, I need to pass S array 3. What does S array 1 represent? I know that S array 1 is a pointer, right? Because I initialized the pointer here. But I know that S array 1 is a pointer that is pointing to what? It's pointing to another pointer, right? Because the whole array has a pointer itself, right? So it's like a double pointer, or what we call a pointer to a pointer, right? So the way, so what did, the way we understand pointers or double pointers, but let me first, there are questions here. Oh, come on, today is a very interesting day. So you guys hear me now? We are good now. Okay, I'm not sure how much you lost, but that's okay. I was going to kind of discuss the double pointer anyway with another example. So if you lost anything, you really didn't lose much. So what I was saying is that here, if you have a pointer to a pointer, because S array is a pointer and it's pointing to an array itself, which is a pointer, this is called double pointer, right? So some of you asked today about this in the tutorial, and we said we're going to discuss double pointers today. So this is the time to discuss double pointers. What is the main idea behind double pointers? First, we know that a pointer is holding an address to another variable. So if I define an int variable called n, and this is a pointer of type int, then the address, let's say this is the address of n, f, I'm going to hold the address here, right? But we know also that the pointer itself is a variable on its own, right? It has the value of an address, but still a variable, which means I can define another pointer, pointer 2, that just holds the address of this pointer. And in this case, I can call pointer to a double pointer, correct? Double pointer is not actually, double pointer is not the pointer that is pointing to a double. It's a terminology means a pointer that is pointing to another pointer, correct? Yes, Nicholas, that's correct. So that double asterisk means you have a pointer like pointer 2 here that is pointing to a pointer that is pointing to an int, right? And we will have more examples like this now, right? Good. So what we are saying here is we know that the name of the pointer array, like the array itself, the array name itself is a pointer to the first element, right? So by defining a pointer of an array or array of pointers, the name is going to represent the address of the first element. This is the rule that we all know. The array name is holding the address of the first element. But what is the first element in this case? It's a pointer, right? Which means BB is holding the address of a pointer. In other words, BB is a double pointer, right? Good. which means it's a pointer that is pointing to another pointer that is pointing to an int, right? Good. Two pointers that points to the same thing. No, Sarah, that's different. Two pointers that are pointing to an int, like what we have seen today in the tutorial, both of them is a single pointer because it only points to an int. A double pointer, on the other hand, we'll have more examples now for those who are confused, but simply a double pointer is nothing other than a pointer where the address that it holds includes another pointer. So it's like a chain, right? What is the double pointer? We will come. So okay. So I will hold on the remaining two questions because we will find their answers now, right? So a double pointer again is a pointer to a pointer. The way we would do this is, so far we don't have any double pointer. We have the normal thing that we know. You define an int, you give it an initial value of 100, and then you make a pointer that is pointing into it. Simply, this is this. You defined A, it has this address. By defining the pointer to hold the address of A, you just copy the address here, correct? And then you make it point to the value of A. So far, so good, what we have done in the last 3 lectures. Then, what if I want another pointer that points to B itself, which means take the address of B. Now I need to define it as a double pointer. Good. So the way this will happen is you define BB as a double pointer. It would have the address of the first pointer. So why it's called double? Because it holds the address of the pointer. So it's pointing, if you look into this, the double word came from the sense that you are pointing to an address that points to another thing. Good. This creates all kinds of possibilities, right? If I want to dereference B, dereferencing B is giving me A, so it's equivalent to 100. Dereferencing BB, on the other hand, is going to give me B itself, which is the address of A, right? In this case, it's 0x22AA00. Double dereferencing B, as you can imagine, is equivalent to dereferencing B twice. In the first dereferencing, it's giving me B, like what we have said here. In the second dereferencing, it gives me A, right? Now, let me see if there are questions. Do you get syntax if you instead defined it as int B? Oh, yes, definitely, Ian. That's a good question. If you didn't define this as a double pointer, so let's see why. That's a good question that is important to discuss now. So what Ian is saying is, if I just define this as the following, and I have done this, would this be legal? For sure, no. Why? Simply because of the rule we said before, is the type you put here is the type of the variable that the pointer is pointing to. By defining it like this, you're saying BB is going to point to an int. But on the other hand, you make it point to a different type, which is a pointer. How can I understand this given what we discussed so far? You can also understand, you look into it from a different point of view, which is, you know that BB needs the type of what is going to point to. In this case, it's pointing to a pointer of type int, right? Because the rule we mentioned about defining the type pointer is you need to declare the type that the pointer is pointing to, and in this case, it has to be a pointer, which is the first asterisk, right? This is why we need double asterisk for the 2 pointer, right? Or for the double pointer. Is that clear now? Okay, good. So some examples. This is going back to what we have done before. BB is a double pointer that holds the address of the first element. Every one of these array of pointers is pointing to another array. We know that BB is holding the address of B0. That means now if I dereference BB, it gives me B0, which in itself has the address of A, right? This is A, this is B, and this is C, right? And then double dereferencing B is going to dereference BB0, which is going to give you A0, right? A similar thing, if I want to access BBIJ, it's like saying BBIJ is going to go somewhere here. So like saying, let's see if there is an example. So if I'm going to say BB0 1. What is this is giving us? BB0 is this one. 1 is the first element, which is equivalent to say, I'm doing BB0, which is giving me the pointer, and then doing pointer arithmetic and then dereferencing, which is also giving you 1. Then this is also equivalent to say, I know that BB is a double pointer. I'm adding into it I, which is the first one, in this case is 0, dereference it, which is giving me B0, add 1 into it, and then do the dereferencing. All of this is going to give you 1. If the last one is not clear, because you might get questions about it, let me say it again. Take it a step by step. BB is what? Is the address of the first element. Adding 0 into it, it would still be the address of the first element. Doing dereferencing for it is going to give you BB0. Add 1 into it is going to give you B001, and then dereference it is going to give you 1. Let me see if there are questions. So if BB is n type, how BB cannot be of n type. BB is a pointer, so it's a pointer type of a pointer, right? But the other pointer that B is pointing to is of type int, right? Give 2. Yeah, it should give you. Oh, I'm mistaken. Sorry for this. You are correct, Nicole. Thank you so much. It gives 2 because I used 1 instead of 0. That's correct.